And we are quite happy. It's been recorded. According to your wish, once again. We have finished everything. Formally, we have finished everything what is related to your program in terms your exam, in terms you made to pass exam. But you still have bachelor work to do. Pre-graduate class, which is intertwined practically with assembling, it's rather difficult to distinguish where we're talking about assembling, especially in second half of semester when we mostly talk about jigs, coordination, coordination of tooling, coordination of jigs, and so on. Everything is about bachelor work also. Uh, one of your tasks in bachelor work, you see item 233 about assembling, is to calculate tolerances and to calculate accuracies. And these two calculations, they are so similar, they are so close, that students may be even misled. What does it mean? What is the difference at all? Above all, I forgot to open previously one more file again. Remind you, actually you see it's already written in front of you. Да? Technical specification with assembly tolerances in design documentations in design project. It's given only for aggregates. So you might know only aggregate tolerance as a whole, like wing tolerance, wing outline, for instance, outer contour of wing, should be not worse than. But what is about the spa which is inside of wing? Or what about the or what about the frame of the fuselage? You can't say what is your tolerance. Once again, remind you what does it mean tolerance. Just in case you forgot, my dear people, tolerance is maybe not in here is that in this slides either. Just in case. And before this, in summer, if you remind me, I will send it later to you. If you remind, if you not remind, you will search it for on your own. You may scroll photos in channel, and you will find similar things. Look at this tolerance. What we understand as tolerance, the limit of allowed variation of sizes. So we have no dimensions, it's numerical expression, numerical representation, let it be, of sizes. So dimension we understand like some engineering designation. And the real sizes of real objects, they may deviate, they may vary from the value which is given in a drawing, so-called nominal or basic value. And the deviations which permitted by designer, they are called tolerance. How we characterize their deviation at all? Deviation is characterized with value of error. So difference between given size, which is given nominal in a drawing, and real size of object, it's so-called error. What is tolerance? Tolerance is limitation of sizes or limitation of errors, by another word. If you count something from, no, in absolute value, the size where it was out, for instance, here, that is dimension which show the size between one side, left side, and right side. Really, in real life, these dimensions may be less than given in a drawing, greater than given in a drawing. And the difference, now I will try to draw the line. And the difference between the real size, this difference, and size given in a drawing, it's called error. So if you're talking about tolerance, tolerance may be understood as upper variation, upper limit, lower limit of sizes, or it may be understood as maximum and minimum error. Да? Ну, actually, maximum plus error and maximum minus error. Positive and negative. Так, let's come back to slides that we are talking about. So, question is, first, in the first item, you don't know what are demands for your unit which is inside of either wing or fuselage or whatsoever. For instance, those who have rib, what you see, example, maybe rib of wing, of flap, of aileron, of whatsoever. So what is the top level for rib, the aggregate for rib? You see it here. What is the top level for spa, depending of which aggregate you have? John, remind me please, what aggregate you have? Aileron, rudder, what is it?
Rudder. Rudder.
Rudder. Great, rudder. No, and the same about frames, beams, panels, whatsoever. What Angelic, for instance, has beam of the fuselage, as far as I remember. Да? Next, sorry. You see, before assembly error calculations, we should calculate unit tolerance. Well, people, usually I use example. Do imagine that you are working and you are getting your salary. Salary, it's no tolerance, да? Tolerance for your living. No, you can't get more if only you steal somewhere, do forgive me, or if you inherited money from someone else. So you have tolerance, and inside of this tolerance, your salary, you should live during the month. That is clear? This example, this analog is clear? Hello?
No,
No?
I don't understand the salary part.
Salary. I see. Salary is the money that when you work, you are getting during each month. Let me salary to write this and say me which language you understand. Urdu. How it's called in Nigeria? Another language. No.
Nigeria speaks English.
I see how you speak English. Так, look, Urdu is Pakistan. I forgot already. Fixed regular payment, typically paid on a month or bi-weekly basis. Да? You see?
Yeah.
Так, now everyone understand what does it mean salary?
Yes, ma'am.
The payment that you got during months, it's called salary in English. Thank you,
No,
people.
ma'am. I understand what salary is, but the what you're explaining about the tolerance for the salary.
Look, I'm trying to give you, it's called analogia. Wait a second. You see?
Yes.
Да? Example, like parallel history, parallel story. What do you imagine? We're just trying to use example. Do you imagine that you have got salary and you need to live during 1 month with this salary? Is this clear?
Yes.
Salary is your limit for life. You may spend less, but you can't spend more. Is this clear?
Yes, ma'am.
Salary is tolerance. It's an analog of tolerance for size. Designer gave you tolerance. Yes. You are inside of tolerance. You are inside of your salary. You can't spend more. Clear?
Yes, ma'am. It's clear.
Next, now you need to decide how much you may spend for food, for your entertainment, for books, for education. How you will decide it? How you will calculate how much you may spend out of this salary for your food, for instance, during the month. I'm not talking about how much food cost. I'm talking only about your limits, how you will set limits for food and entertainment, for instance. Will you spend all the salary for this?
No.
Yes? or
No,
not?
no.
No. What are compulsory, no, let's say, exclusions, compulsory substitutions from this salary? What you should divide, or which purposes you should divide money for?
Education.
Education. Pradip, I'm pleased, but I'm afraid first you need to think about how to pay for your apartment and communities. Water, electricity. Am I right?
Yes.
Yes.
Yes, in order to live up to next salary, to survive up to next salary, you need to live somewhere in apartment. You need to have electrical energy. You need to have water. No, what else? In our country, heating system, at least. At least. So at least you have pay for apartment and some communities. Once. It's a called compulsory spendings. Next, are you live immediately at the office or you need to get to the office by some kind of transport?
You need to get by transport.
Yes, either it's by bus or by train or taxi or whatsoever. You also must have some money for transportation yourself to the place of where you're working. Agree?
Yes.
So there are, even inside of this tolerance, which is your salary, there are things which are not yours already. They are preliminary already, not yours. You have no access to this portion of salary, or you will not see your next salary. Agree?
Agree.
Very well. So what is tolerance? Limits, yes? And the whole salary, it's, do forgive me, let me to find where we may write. Oh. Very beautiful, but it's not. So let's try at least. Wait a second. You see explanation for Ukrainian group now. We will do explanation for ourselves. We will do it simultaneously with what we are talking about. First item is calculate the tolerance. Yes, I just... Calculate the tolerance. Upper and lower deviation for outline assembly of assembly unit. What is tolerance in your case? Look, we have salary. Salary is equal money for food. Alena, do forgive me. Girls, education, whatever. Да?
Oh.
Plus some compulsory things. Let's call it, да? And what we will understand as these compulsories. Once again.
Rent and
money
Yeah.
for transport. I don't know. No, transport
Yes.
money. Да?
Yes.
Look, in terms of tolerance for in terms of tolerance for airplane, да? Tolerance. Опа. What happened? Tolerance for aggregate. Ну, let it be tolerance for wing, да? Equal to tolerance for rib. Wait. I'm so awkward. Tolerance for rib plus these compulsories. And question is, what are these compulsories only? We have some compulsory errors, we have some compulsory mistakes in manufacturing. First, we assembling the rib, the spar, that is, let's designate it with some another color. I don't remember already which color I used here. Pink. Okay, let it be pink. Tolerance for rib, it will be with not такое. Not normally visible. Тогда такое. Tolerance for rib. And here is, as I said, whatever you may spend free, let it be according to your wishes. It's inside of these brackets. Tolerance for rib, it's how you assemble the rib. It depends on you. You may use assembling by assembly holes, not in real life. No? Assembling by CFH, assembling in a jig. That is depend on you. But first you need to consider some compulsories. And what are these compulsories? Well, above the all, it depends on assembly methods. Look, the tolerance anyway depends on assembly methods. I do not remember how far it's now from the place where we are, but when we studied assembly methods together with you, you have seen such slides. Actually, we have it right now. What I'm doing. We have these slides here. Yeah? I'm searching for photo. I know why I'm searching for photos. Because to deal with these slides, it's more difficult for me. I hope you do remember those places, or at least those photos, those pictures. When we were talking about assembly methods, each time first we draw a sketch. Next, we consider their sequence, let it be, of assembling, what is really happened there, how they do it. And we compulsory also were talking about so-called errors, deviation of sizes they might be during this assembling. And we were talking about accuracy. Each time in a corner it was written equation of errors and statistically proving accuracy of that or another technique by skin, by mockups, by inner surface of, by outer surface of frame, by air frame. You see values each time by CFH, and these values, they are different each time. Why they are different? Well, because we understand, I hope you understand, that if you use that or another technique, it may be resulted in accumulating of different errors of different objects. The far original base from the far from theoretical outline, the far from theoretical outline we start, the worse will be the value of error. It's obvious. Look here, we starting immediately at the theoretical outline because we have contour locator which should, which is not coincide but should coincide with theoretical outline. Of course, it has some deviations because real object might have deviations from theoretical values. But it's at least try to repeat theoretical outline. And in this case, accuracy will be the best, as only we are moving far from theoretical outline. What like here, for instance, CFH, we already made some steps back inside of airplane and starting somewhere in the middle and assemble with accumulating errors of different types. And as a result, we have accuracy almost twice more than accuracy of assembling by skin. So as you might see, accuracy will depend, accuracy that we are trying to talk about, will depend on assembly method. including those assembly methods which now I have reminded you only methods which related referred to jigs, assembly methods, which methods of assembling in jig. But really, we also have some methods which are without jigs. I hope you do remember. Assembling by marking, assembling by surfaces, assembling by assembly holes. But story is rather similar anyway in most of cases. And in our case, when we are talking about particular assembly method, pay attention. Here it said consider, calculate the tolerance, consider the tolerance for two variants of assembly and coordination. Actually, you use only one variant of assembly method. Normally, you take method by outer surface, I mean by skin, because first part you are trying to locate usually is cap or rim, or if it comes about panel, first part will be the skin, and it means that you are using this technique, locating onto outer surface of skin, if even you have no skin in your assembly unit. It's just the name of method, no more, да? And you are selecting one assembly method first, and next you are working with two different methods of coordination. But first, you are fixing some assembly method. And if we're talking about assembling in a jig, what are these compulsories? Compulsories, what is guilty in appearing of these extra spendings, let it be? Jigs. If you assemble the wing in the jig of wing, and if you assemble the rib in a jig of rib, or whatsoever it will be, spar, panel, doesn't matter. If you assemble it into different jigs, may they be a little bit vary from each other. Whatever accurately you're trying to produce this locator, this orange thing which is represented in the scheme, however accurate you are trying to make it, they will be not completely identical. They will be different. And it means that as a result, you will have different errors of these jigs. The jigs are different. It comes about jig of, here you might see, it comes about jig, what, how? By comparing to accuracy of two jigs. The jig of aggregate and jig of your unit. Here I'm just reminded you what are these couples of aggregate and unit. Next, how we may calculate accuracy of jig. That, people, we have already done in our laboratory work about mounting standard. To remind you, you were doing something like this. You were writing down the chain, and we did similar things at third year when we, I hope you remember this, measuring with microscope, with dial type measurer, indicator, dial type indicator, when you were working with loft, with diastole, and so on. And next, you were calculating what is the final value, expected value, of course. What is expected value of these errors? So some technique itself you already know rather well, and it's not difficult. The story is where to get this chain of size transformation. When it was in class, when it was in your laboratory work, it was it was obvious. No? When it was about assembling mounting of jig by mounting standard in laboratory work, it also was obvious because it was explained, and because you know that assembly jig was made by mounting standard was made by counter standard, it was made from surface standard. You see, I'm moving backward a little bit. No? Surface standard in turn was made from framework of working templates, and templates has appeared from system of lofts. So history of this object, you know, and how to calculate the error of this jig, the error of this object. No, it's not difficult. You just need to calculate all the errors, all the stages of manufacturing of the jig, and you will know what may be possible deviation of this jig, what is this difference, this what I'm showing right now, is related to this case. You may say that possible errors will be in a range, and next to calculating the range. Real object, it has one error. What one real object, it has one error in this place. When we are talking about calculating of errors, we don't know what real objects will be, but we may talk about some probability that 100 of objects will be in a range of. And you are calculating this, as I'm already reminded you here, now, as result of errors accumulating at each stage. At each stage, it's very little error. As a result, it will be a little bit more. No, for instance, in a jig, after calculation, it's appeared plus minus 0.3, if I'm not, 0.31, something like this, or 0.27, around this. If you use theory, it's called probabilistic theory. In this case, it shows realistic results. If we will use method of maximum minimum, of course, it will be much greater result, but in real life, they are not realized such results. In real life, realized probabilistic results which correspond to probabilistic theory and to so-called Z1. What you see, да? Gauss distribution or Gauss law of distribution of sizes. One more time, remind you also, you must have heard it in video classes that I sent. I already repeated it so many times that I do not remember whether I used immediately on you this example or not in real class, or you just were watching video. Pay attention here. What do you imagine? And certainly we use this example at your third year. We have a box with little cubes, да? What do you imagine? Such a toy for children. Box and cubes. What is the size of box? 20. And what is tolerance of box? 0.4. 20 plus minus 0.4. You have 4 cubes inside in line, and size of each cube is 5 centimeter. In order cubes are inserted into a box normally. What should be the tolerance? If here you have tolerance 0.4, how you may propose, John, what should be the tolerance of these cubes? John, wake up. May it be 0.4 also. Each cube might have 5 plus minus 0.4. May it be? Yes, no. Oh, yes. Answer, please.
Yes, ma'am.
Once again, yes or no?
Yes, yes.
Yes? Okay. Then do calculate. At least approximately, without theory of probability. What will be the maximum possible value in this case? 5. I have seen it yesterday somewhere. What on? Wait a second, it's appeared. What do you imagine that we have 5.4, the maximum possible size in this case, if tolerance is plus minus 0.4 here, then 5.4 4 times, What will be the possible maximum size? Умножить на 4. Does it correspond to the tolerance?
No.
No. What should be the tolerance here May it be the same in tolerance for the cube, or it should be less?
It should be less.
Yes, obviously it should be less in order, in the worst possible case, when you have some assembly components inside of box. Altogether, they give the tolerance not worse than. Is this clear?
Yes, ma'am.
No, it's not completely correct example to the questions that we are talking about. But do you imagine that you have a wing, and inside of wing you have ribs, you have spars, you have panels. The box is a wing. Inside of this wing you have spars, some ribs, some panels. We have tolerance for the wing given by designer. Tolerance for assembly units which are inside the wing should be more accurate or less accurate. Tolerance for them should be more strict than designer gave for the whole wing. No, it's not difficult question, John.
I didn't hear you. No,
You didn't get it?
no, I didn't hear what you said.
No, do forgive me. Maybe it's problem of internet that it slowed down in my computer, and maybe also your computer, because I'm not clearly hear you. And other people, they are playing dead. Вот Alena, Pradif, Angelic, they pretend that they not here. They're just afraid to open mouth and say something. John is the only who is at least trying to reply. Once again, let's forget about all this. And Alex, you have two jigs. You have jig for the wing and you have jig for the rib. And jigs give you different results. They have some deviations from each other. What you might do, you may compare these two jigs, and no, as I already said you, tolerance for wing given by designer is greater than tolerance for rib. Look at this. Tolerance for box is greater, it's 0.4, than tolerance for one cube. That is too much simple example. Actually, it's let's say too direct, too literal. It's not completely correct when it comes about assembly in jigs. Not completely correct, but idea is rather similar. In order you assemble something with demanded accuracy, the assembly component that you are working with, the components of assembly unit, the components of aggregate, they should be a bit more accurate normally if you use the same assembly method for both of them. In real life, it's not quite like this. It's not quite so direct, not quite so literal, because you might use different assembly methods. For instance, on assembly of unit, you use assembly holes, or you use CFH. And when it comes about the assembling of aggregate, you will use outer technique, outer surface technique, and it means that you may compensate the error of assembling at the stage of unit assembling. At the stage when you use the assembly holes or CFH, you may compensate it by more accurate technique at the next stage. But in real life, these considerations not are ideally the same as we're going to do right now. But in your bachelor work, you working with the same assembly method for aggregate and for your unit. And that is why in your case, you just need to compare two jigs. What does it mean to compare two jigs? Once again, you need to compare their accuracy. And their accuracy, once again, remind you, it's practically the history of their manufacturing, of their pre-production and manufacturing. So in order to assess, in order to esteem, evaluate this accuracy, you need to write down chain of jig manufacturing. But pay attention, when it comes about one airplane, yes, it's the same airplane. Certainly, all the airplane is shown in this theoretical loft, in the system of theoretical lofts. No, when we are talking about one aggregate, we have one theoretical, the only theoretical loft for aggregate. Next, it's redrawn to the system of design lofts, which practically are design drawings in scale 1:1. And next we do photo on metal, and next. No, it's in old-fashioned techniques. What it looks like in modern manufacturing, in modern life, or at least what it's supposed to look like. You have 3D model of wing, 3D models of ribs, of spar, of whatsoever. You know, you worked in solid, yes? They are all elements of the same model. No, for instance, you have 3D model of, I don't know, of a die or of jig. And in what this 3D model of jig as a whole consists of, machining jig, it consists of some parts. And these parts, yes, they are separate 3D models also, да? Separate files might be, but they are all elements of the first 3D model of the wing. And these 3D models altogether, they are called digital mockup of airplane. In Western countries, they understand it as digital mockup. They call it digital mockup. Actually, digital mockup, it's even more wide idea, more wide concept than just a system of 3D models. But at least those things you already must understand. That we have digital mockup, and elements of the digital mockup 3D models, they are also like related to each other, intertwined. And here is the mistake by the word. Look at this. No, we will fix this mistake, I hope. Look, we creating such chains, the chains of history of jig manufacturing, or the chains of some object. Let's not talk about which objects right now. Да? We're creating such chains, and next we're calculating with these chains. For instance, in this scheme, how may I understand where the what is the error of this jig of wing? How may I calculate it? I should pass along this line. Like it was an example with one line where it was here. Да? I should pass with one line from beginning, вот так, да, to the end. Calculating all through all these stages, and you already know what is the error of jig. Okay, let's come back. Once again, in order to know what is error of jig, I should do calculations along this line. What about the jig of skin? I should do calculation along this line. I should consider all the stages along this line. Well, but no, let me to cancel these changes. But what if I have to compare? Так, как тут наквашено все? Да. What if I have... they are not separate. Да. What if I have to compare the two jigs? I'm not interested to know what is separate accuracy of, no, here is jig of fuselage, not of rib, sorry. Jig of fuselage and jig of panel. In order to calculate the accuracy, I might use, wait a second, saving. I might use the way of calculation, as I said, passing like this and passing like, oh, sorry, and passing like that. Yes? But I'm not interested in separate accuracies. I'm interested in accuracy of coordination in the difference of the accuracy. Look at this. I will even copy it down now. This, if I master to do it. These three objects, and let's group them, and let's move them. Look at these lines. No, I understand that it's not ideally visible, must be. It's symbolically represent the ways you need to pass. The top line, accuracy of one jig, the bottom line, accuracy of lower jig. Pay attention. First, some steps, they pass it together. Do they have difference at these stages where they comes together or not? May difference appear at these stages? If it was no, certainly not. Where difference may appear? Only these lines separated. Yes?
Yes.
So error of coordination is calculated along the places which are separate, which are not the same. This red line represents, approximately it's represent the way you need to pass to calculate error of coordination. Why error of coordination? Once again, you need to understand difference between two jigs. And this difference, those two compulsories, something different inside of two jigs will be responsible for not ideal coincidence rib and the wing. No, because we're assembling in two assembly jigs. Now, in this case, in case we're assembling in assembly jig, it's proven that difference between jigs depends in some miscoincidence of wing and rib while assembling. No, to be frank, it's I said wrong. Not miscoincidence of wing and rib. Some miscoincidence of wing, which consists of these ribs, spars, to expected values. Well, let's come back here. So we need to know the error of coordination of jigs. Let me delete this one, and let's come back here. Look, formula. Here is the formula. And this formula you have seen in a book also, I trust. And in explanation, video explanation, you have this video explanation with the same slides. You have video class. If necessary, I will show you once again where this video class for bachelor work, explaining of with using of these slides, let it be now. And it was in progress, in front of you. Not you, previous group, but whatsoever, the same. Pay attention here, once again. We have created the chains which correspond to history of jig manufacturing, history of part manufacturing. Which part? What now it's important, which part? The part which should be in touch with contour locator of jig. In case of this panel, it's a skin. In case we are talking about the rib or spar, it will be another part with another name. But each time the same consideration. Something that is in touch physically, touching the contour locator. In case of John spar, it's more probably it comes about the caps. In case of angelic beam, it comes about bottom and upper, I don't know, maybe caps also. I still have not seen, but list. In case of Alena rib, it comes about caps of rib. Clear or not? Names of parts may be different, but approach is the same. You need to identify part which coincide with outer contour. For panel, it's a skin. For rib, where is it? We have seen somewhere for rib, yeah? What? For spar. Well, You see, spa.
Yes.
Да. No, in Ukrainian already, sorry. And why we draw 3 chains at once? Why you see 3 chains? We need only 2 chains right now. Because next stage of your calculating, it's already calculating between, you see, another marks has appeared. You see this line, which certainly talk about the error of the jig itself, jig of panel. Certainly one more error of coordination has appeared. It's already another stage of calculation. Approach will be the same, formal technique is the same. Those things that we have studied. What, to remind you, here is the photo from slides, explanations of classes that we used. Yeah? You see it. When we calculating the when we started calculating of accuracy, it's out of list of for your exam. We were doing the same things actually. We have created the equation of errors, and next in this equation of errors, we analyze it, which things we must calculate, which errors we must calculate, which errors are statistically taken, and how to calculate it, these errors. To draw the chains, and these chains next are necessary to calculate around. What these chains depends on? They depends on method of coordination, history of manufacturing. The most of this history depends on method of coordination. In case of manufacturing of the to another part, it depends on technology of part manufacturing. Here is what this last chain. It depends on how you're producing the part. But how you're producing the part is here. But for skin, it's bending punch. What that is history of producing the part. Why skin of this shape? Because it's copied the shape from bending punch. And that's it. Manufacturing is finished in this. Because everything that was before in this chain, it's history of manufacturing the bending punch, not of part. If you're watching in another place, what cap of rib, why I see cap of jig of rib, jig of spa. I have too much slides. I'm ready to not remember even how much I have. No, you see, да? Stories are very similar. We just use different names for practically it's the same, да? Practically. We use different things for different chains we drawn for different how it's for different types of units. Well, let's come back to this one. We need to calculate once again. What we need to calculate? We need to calculate step by step the error of coordination. And here it's even already calculated. Do forgive me, it's too much complicated for me to write it like no, like in Paint. Да? In this system, it's not possible to write, and only by text. And how to calculate it? I hope you recollect. We have formula, this beautiful formula, which says this theoretical probabilistic story, да? Расположить за объектом. Отлично. Не получается расположить на задний план. Да. Look at this. Whatsoever it comes about equal to. What it equal to? Sum of middles and plus minus square root from sum of squares, but halves of squares. What this half of squares? And we're coming back to this bell-like distribution. All those things we have studied, not one time, more than one time, do forgive me. What it comes about? That, do you imagine that you have one stage of size manufacturing, another stage of size manufacturing, and each time the stages, they may be a bit different. They may be quite the same. Where it's reflected in these values. These values, what do you see right now here? These values, they are so-called possible upper and lower possible deviations of object during manufacturing. Again, it's statistically known and makes it written in reference book and standards, in instructions, that if you do that, if you use that or another technique of manufacturing, for instance, you are working with what sand mold bending punch, you are working with casting. You had sand mold, and from the sand mold, by casting, you do bending punch, copying bending punch from sand mold. In this case, deviation, possible dispersion of deviation is like this. What if you are working, for instance, you do sand mold from templates by stuffing the frame of these templates, templates of cross-section or framework of working templates of cross-section, and you are sticking inside the bricks of wood, or you are working with plastic or some cement mass whatsoever, but you are not copying it, you are constructing it. And next, you are processing in cross streamlines, for instance, with spirals. In this case, you may occasionally deviate s to the plus, s to the minus. No, someone who do it may do mistake to plus to minus because they do it manually. They do not copy it. And in case of casting, you can't penetrate inside of casted form or casting form or forging die, for instance. You can't penetrate inside. You may do part either equal to forging die or less than forging die, but not more, certainly. And when you are working with cutting instrument, you may do mistakes, you may do errors as greater object as less object than necessary because you use cutting tool. Well, now again, I forgot where the slide we have used. That one. Do imagine that you have some these deviations, such curve, or this curve symbolically represents this deviation, represent probability of appearing of Z or another size. What? Let me to remove this. Look at this. What do you see here? This arrows, not errors, are arrows. No? These dimensions. They represent appearing of dimension of you trying to produce the same object, but you may do it a bit less than nominal one. Nominal is this one, this little bit this red line. Let's do it red. Red line, and let's do it much thicker. That is your nominal size. You should strive, you should do something with this size. But instead of this, or this demanded size, instead of this, in real life, object may be a bit less, a bit more, and they may be with different sizes. You see, I'm clicking this set of sizes. Do imagine that you have produced the 100 of these objects, and next you measured them. You even were doing similar things in laboratory classes, interchangeability, and so on and so forth. Maybe machining, also you do similar things. Really measure the batch of items in order to understand this distribution. And next you are counting how many sizes you have in that or another range. The whole tolerance is here, one line and another line. Yeah? Actually, these lines are also supposed to be red for us because they are red limits. We must be inside of these limits. And real sizes that you see, they you may meet what sizes, like between this and this value, you may meet, for instance, 5 times among out of all 100. Sizes which are in a range from here to there, you may meet around 60 times from 100. No, to be correct, here we have 2%, here we have 33%, and as we have it symmetrical, so middle area is around 65%. Altogether, this middle middle on the left, middle on the right, they are around 30%, and these tails little bit, the thin elements on the left, on the right, altogether they give around 5%, even less. And everything that under the curve, what this plus minus 3 sigma, so called, everything that is under is almost 100%. It's 99.99 or 98%, something like this. So practically it's cover all the possible probability, all the possible cases of size appearing. The most of sizes rather close to the nominal. The far to these limits, no? The far to the width of distribution, the less sizes you meet. So once again, the whole area under the curve is always must be the same. But in one case, curve is wider. Curve is wider but lower. In other case, curve is more narrow and higher, as you might see. In order to characterize this curve, what do we use? We use characteristic which is called middle. Middle of this field is, of this pink field or lilac field, is here. Middle of green field is here. Middle of yellow field also somewhere here. I try to draw it symmetrical. How to understand where will be the final curve? What is the final curve? How to understand it, you have already seen. First, according to the formula that we have seen, first we are trying to summarize all the middles, all coordinate the middles of fields. And next we do calculation the square root, this so-called vector sum of halves, because each of these distributions is characterized with coordinate of middle, you see, which actually in our case it's correspond to the nominal size, yes, and this deviation. What is deviation? Look at this, 20 nominal size. Oh, sorry, I did something not ideally. Maybe it's grouped object. Yes, ну, разгруппировать. No. 20, да, is plus minus 0. How we may write it also? Look, may we write it like this? 20 plus 0 plus minus 0. So nominal size and field of distribution. Is this clear?
Yes, ma'am.
Let's try now to understand what next example we will use. Вот смотрите, 19.5, 19.9. How we may write this demand of tolerance? Look, it's 20, да? And what is next? 20. What is next? Minus. Ой.
Point.
Да. Minus 0.5. Да? And minus 0.1.
Minus 0.1.
Да, exactly. May we write it like this? Yes, we may. But what is another possible way to write the same? In terms what I have shown you here, like middle and halves. Look, 20 plus what?
0.5.
Look, what is the difference? What is the field of dispersion of sizes in this case? 90.5, 90.9. What is the difference between them? 0.4, yes? Agree? Don't pay attention now to this. 0.4. Am I right? Hello? 90.9 minus 90.5. What is it? 0.4?
Minus
90.9, 90.5. What is the difference between these two sizes? 0.4, yes?
yes.
Yes.
Now, how may I write down to calculate on your own? Minus 3 must be here. Minus 3. Sorry, I did mistake. Now, do calculate. If I write it like this, what you will have? Minus 0.3, да? Plus minus 0.2. Or it may be understood as 0.4 divided by 2. The half of field of distribution. The whole field of distribution equal to what? Semi. 0.4, yes? The whole width. I'm about to cry, people. What is not clear? It's so simple.
Ma'am, sorry, my network went off. I don't understand where
Your network.
minus
Okay,
0.3
your
came from.
network. Your network. What about other people? You are not the only in class. As I see, communication like with counteraction with you doesn't work. Alina, Pradip, Angelik, please help me. Look, size. Let's imagine that constructor said that size, what in a drawing, size is given like 20 minus 5 minus 0.1. What does it physically mean? In millimeters. Like this, 90.5, 90.9. Agree?
Yeah.
Next, how we may write down this demand of designer in another way? We may write it like this: 90.5 lower deviation, 90.9 upper deviation. Yes? Yes. Let's try to add in this example. $90.5. What visually, what do we see? 90.5. Ой, горе. Каждый раз для того, чтобы поменять цвет, это надо такие действия предпринимать. Это просто катастрофа. 90.5. You
Yeah.
see. At this place, what we will see at this place? 90. point semi 9.
Mm.
No. 90.9. And now question is, this middle, what it correspond to in case of blue values, да? In case of these values that I have written in blue. Как он мне надоел, скачет как. How to find middle? This line. How to find coordinate of this line? If it was symmetrical like this, 90.9, 20.1. In red color, it was 0.
Yeah. The middle will be if for the
Mhm.
19.5 and 19.9 to be 0.2.
Mm-mm.
Huh?
Mm-mm. For red colors, it's 0, yes?
Yeah.
This 20, it's 0. What? 0 plus minus 0, 1. Да? 0 minus 1, 0 plus 1. And it will give results 90.9, 20.1. For this one, I already wrote it even. Look. Look.
Uh,
20 minus 0, 3. Calculate it. 90.7. Да?
yeah.
How to get 90.7? How to get 90.5? 90.7 minus 0.2. 90.7 plus 0.2. And you will have 0.5, 0.9. Yes?
Yes.
It's just another representation of the same information. That one,
Mhm.
and that one gives you the same results. Is this clear?
Yes, ma'am. Understand.
I hope. Well, once again, how to work with these fields? You need to understand where you have a middle. What is coordinate of middle? Coordinate of middle with respect to the basic size. Basic size is this one. That is basic size. Да? 20. 20 each time. And when you are talking about middles, you are talking about what is like difference between this when we are talking about these deviations at all. What is the difference between basic size and these ranges? But look at the diagram that we have here. Plus minus 0,2. Plus 0,2 minus 0,2. What it corresponds for? It corresponds to the red case, let it be, да? When we have symmetrical field, and it means that we have middle 0, and we have plus 0,2 minus 0,2. What about if we have, look at this, who is whistling? Those who whistling will not have money. It's superstition, don't pay attention. It was a joke. Look at this. Plus 0,3 minus, minus 0. Can't be minus 0. It's maybe only 0. Yes. Plus 0,3, 0. Да? It means that curve is, with respect to the basic line, the curve is, but with respect to the basic line, curve is somewhere here. Oh, sorry, I did mistake. Oh, how to move it? Похоже, что никак. Вот так. What does it mean? That it's сгруппировать нельзя, да? Ну и ладно. That is plus 0,3 minus 0,3. It means that it's somewhere here. Where's the middle of this place? Of this curve? Where it's middle? Here.
Yeah.
Да?
Yes.
And how to calculate what is What is the middle? If it start on 0 and finish it on 0.3, how to calculate where's the middle? It's obvious, maybe here already, no? Where is it? Between 0.1 and 0.2.
Yeah.
0.15, yes?
1.5, yes.
Done. If it comes about this one, pay attention, this purple one. What? Oh, what? I'm sorry. What? You see, 0 minus 0, 1. Plus 0. Зашибись просто. Plus 0, да? 0 and minus 0, 1. Certainly this curve, that one. Where's the middle of it? If it starts at 0, надо вот это удалить. Удалить. И вот это тоже удалить. If it starts on 0 and finish it on 0, 1, where's the middle? Minus 0, 1, да? Where's the middle? Okay.
0.
Minus 0, 1.
0.2.
Minus 0. Ну, давай, 0.0.
5.
No. And next value was 0.
0.
No? Agree?
Yes.
It's not difficult. It's just elementary considerations and your imagination, and that's it. The only really complex thing, difficult thing, it's composition of these chains, how to compose the chain. That is complex. No. Those chains, they are the matter of complication for students normally, just because students have no experience enough to work with the chains on their own. But do forgive me, we have studied diagrams of coordination, these typified diagrams of coordination. What for? In order you might just copy these chains from diagrams of coordination. Because if you rotate upside down such a chain, what you will see? You will see diagram of coordination that we spent studying a lot of our studying. So, if you rotate these chains, you will see the same things that we have studied in typified diagrams, where you had maybe even more of them. I'm not seeing it. Maybe it's lower. That I sent you for different techniques of coordination, this prim, loft, and so on. And you have it in lectures also. I mean, video classes. Moreover, you have it in books, but in books they are not talkative. They are books you need to read and to understand with your imagination, without book not talking to you, in contrary to me, and in contrary to the video class. And look at this. What do you see here? You see examples, some examples of practically the same things that we are talking about right now. That we need to compose chain. And in your bachelor work, you do it for two different methods of coordination. Here, example is considered for coordinate template method and program instrumental method. Coordinate template method, or new name of it, loft instrumental method. It's old method, let's say it old-fashioned technique. Program instrumental method, it's new technique with using of 3D models, computers, which starting with digital mockup, you see. And what you do next? Next, you do what we are talking about already for the whole hour. Look, unit tolerance equal to aggregate tolerance minus errors, error of coordination between two jigs. What is error of coordination between two jigs? Here it's represented with line, you see. Yes? Yes, you see. Good children, you see. And it means that you need to work with these values. How to work with these values? Identify the middles of these values. What is the middle? What this characteristic, this middle? We even use complex example when we use this example with that one, да? 90.5, 90.9, and we have written it in two different ways already. 20 minus 0.5 minus 0.1, the same as this one, another representation of these values. And if you rewrite it in Gauss distribution, what it will be? That one, minus 3 minus 0.2, minus 0.5, minus 3 plus 0.2, minus 0.1. Here you have it in upper and limit deviation. Here you have it, the same upper and limit deviation rewritten like middle of field of distribution plus minus half of field of distribution. It's not difficult. What you need only, you need to imagine the line with values practically, like we did it here, for instance, or there. No? You may draw something like a ruler for yourself if you have any doubts. And on this ruler, you may understand what it comes about. The final curve, which describe the summary deviation, it will be wider, of course. It's wider, and middle of it, it's result of summarizing. It's summary result of all the middles. In real life, these calculations, they may be even a little bit more complicated. Here we use the simplest formula without any coefficients. But in real life, this formula also might include possible asymmetry of this distribution. It's also Bell distribution, but a little bit shifted, not ideally symmetrical. Actually, in my case, no any of them is symmetrical. Sorry, my hands are guilty. And when it comes about the real life formulas, little bit more complicated, you might see it in our laboratory manual. You see it with all the possible coefficients. And moreover, in formula that you see in the most general way in laboratory explanation, in this appendix to laboratory work, you see it even with some possible kinds of distribution. There is coefficient which consider what kind of distribution you have, whether it's Gauss or Simpson or exponential or some another. In our case, when we are talking about the Gauss distribution, one of coefficients equal to 1, and we consider that we have symmetrical coefficients. So we have it in simplified way, this formula. What is simplified way? All the middles, that one, all the middles plus square root of sum of squares of halves. It only seems difficult. Now, what I propose to do, we are making break for half an hour. And in half an hour, I continue explanation of what we have started. And once again, until you are at the break, I will send you the lectures. I hope the lectures of Monday, the classes of Monday, they already has appeared. Downloaded, and I will send you right now the second portion of Monday. And plus to this, I will show you or even resend you where you have explanation for this error calculation, but not so jumpy, let it be explanation, where I made these slides and talk to students and explaining them the same things that we are talking about right now. We are now approximately at this point, but we have not calculated yet. Yes, we only, I hope we only understood, we already understood, even Brinta, who has appeared a minute ago, maybe, that we understand the first point. First thing we need to do, we need to identify what is our aggregate. Next, we are watching in technical instruction what is aggregate tolerance. It's written in the document to the airplane design project. It's given together with drawings, demands of designer to that or another aggregate. Next, you need to calculate the unit tolerance. What we do in our examples, we do it in consideration that you use twice. For the aggregate and for the unit, you are going to use the same assembly method, and this assembly method is method of assembling in a jig. Next, might be differences, I said, depending on assembly method. But right now, we think that we are working in jigs, and in case jigs are different, they might be different. Real objects, they are not ideally coincide with drawing. They might be different to the plus, to the minus. And these differences we're going to include into our unit tolerance. How? We are going to reduce aggregate tolerance by including this error of coordination. But practically, it's correspond to example what we start with. Now, how we may understand how much we may spend on our private purposes like food, meeting the girls, creating the family with honest purpose to create family. What I mean, girls, educations and so on. How much we may spend? Salary minus our compulsory spendings for rent and for transport to get to your work, to the place where you work in, to office, or you will have not another salary next month. How we working with tolerances for airplane pieces? Tolerance for the whole wing, salary. Tolerance for assembly components which are inside, plus these compulsories. Compulsories are differences between jigs. And how to understand this difference between jigs? Write down the chain and calculate the difference between two chains here, jig of fuselage, jig of panel. Identify the place where they start separate and use probabilistic technique to calculate the difference. It's not difficult. The only difficult thing for you has appeared that you do not remember what does it mean. Probabilistic technique, and you are rather slow to understanding how to identify where the middle of field and where the ends of this field. But practically, there is no any complexity in this calculation. Real complexity is how to compose chains. That is really complex for students, usually. Such chains, representations, it's complicated for students. No, for this we have typical diagrams of coordination. Let's stop in the record, and we will continue after half an hour. Is it stopped or not? Seems like not. Record. Stop it.